Why do you do opposite?
Okay. Once again, we're talking about not if I throw something at you, what's the chances I'm going to hit you? We're talking about what are the chances that, I don't know.
Oh, be creative.
I'm trying. So hard.
Then you set it up and it
Okay, here's an example. If I tell you that there is a quarter hidden somewhere behind this wall, and I'd say, what are the chances that the quarter is behind the smartboard? Okay, this is geometric probability. We would take the area of the smartboard and figure out what portion of the whole wall it covers, and that's your chances. That's your probability.
So there's nothing else. It's like a one-sided.
Right, exactly. And so, but today we're also talking linear. Okay, we're going to have linear probability. Like, what if it's a point on a line? For instance, let's be creative. Creativity is not showing up right now. If we all lined up side by side and we were standing in a straight line and a seagull flew over our heads and pooped, and it would be, what are the chances that it landed on Meredith's head?
Oh, I get what you're saying. I see what you're saying.
See what I'm saying?
Yeah. That's disgusting.
Like, but thank God I was
When I
going
was
home to
riding
change
a
to the
horse,
doctor,
a
so I
bird
just wiped
flew
it
on
off.
my head, and I thought it was a pecan. Yeah, because we have a pecan tree, and I did like this, and it was all like.
One time, I was in perfect. Never mind. I'm gonna quit.
Oh, you just told the world.
Okay.
Lisa's something happened.
If I said, okay, I have a point P, which is located on segment AC. And I'm asking you, what is the probability that P is located in a certain place? We would set it up as a fraction or a ratio. For instance, if I said, what's the probability that P is on segment AB? Well, what we're going to do is figure out what fraction of the whole thing AB consists of or makes up.
10.
So we take the length of AB, which is my designated area or segment that I'm trying to see, is it going to happen here? And we divide it by the length of the entire segment where we've been told this thing is located.
14.
And AC is 14 units long. And then remember that in ratios, we always reduce to lowest terms. So the probability that point P is on segment AB is 5 to 7. And that's because AB is 5/7 of AC. What's the probability that point P is on segment BC? What would you do? Well, you take the length of BC and divide it by the length of whatever we were told where it is
2
located,
over 7.
which would be 14. And then we reduce. And the reason the probability is 2/7 is because BC makes up 2/7 of AC. And finally, what's the probability that point B lies on AC?
1.
1. Well, AC has a measure of 14. And AC is where we were told it is with a measure of 14. So what's the probability? 1, which is the same thing as
14 over 14.
100%.
Or
It's 100% probable that point P is on AC. Because we were told that point P is on AC. Okay? Now the second thing that we have is area probability. And I gave you the for instance. Okay? If I had a quarter or a dime or, oh, this would be better because it's more like a point. What if I told you I have a diamond hidden in the wall right here?
We would rip that.
The probability wouldn't matter, would it? Y'all be ripping it off. But, okay, and I said, what's the probability that it's behind this smartboard? Well, this is no longer just a straight line. Now we're talking about a region, correct? So you're going to take the area of the designated region, which in this case would be the smartboard, and divide it by the area of the entire region where I told you it is located, which would be the whole wall, correct? And that's because we're figuring out what portion of the whole wall the smartboard sits on. And that's all we're doing. Okay? If I said an airplane, okay, suppose last night on the news, you were on your way home and you heard on the radio that there was an airplane that crashed into a house in the city limits of Opelousas. All right, how many of you live in Lafayette? What would the probability be that it crashed into your house?
0.
0, because your house is not within the city limits of Opelousas. All right, how many of us live within the city limits of Opelousas? All right.
I know I live outside.
Well, let's just take me for example. The probability that it crashed into my house would be the area that my house takes up divided by the area
Of Opelousas.
of the city of Opelousas. Okay? All right. Let's look at this bullseye. It's very colorful. It's cute. I like it. I like it a lot. Okay? Concentric circles. Y'all remember that name?
Mhm.
That's what this is.
Okay. The white dot in the center is the center of all 3 circles. 1 is the radius of the small red circle. 7 is the radius of the green circle, from the center to the edge of the green. It's not just from here to here. Okay, so let's make sure we're clear on that. And 12 is the distance from the center to here. So 12 is the radius of the big circle. Okay? Now, I'm going to tell you that there is a point Q. And point Q is somewhere on this target. Okay? Now my question to you is, what is the probability that point Q is in the red region? No. What did we say here? The area of the designated region divided by the area of the whole thing, where it possibly is located. So I have to find the area of the red region, which is a circle. And what's the area of a circle? Pi r squared, and the radius is 1, so 1 squared is 1 pi. And divide that by the area of the entire target, because it lies somewhere on the target, okay?
144 pi.
Which would be 144 pi, because the radius of the entire target is 12. So pi times radius squared is 144 pi. Now,